Hello my dear students, I welcome you all for today's session. Myself Vasanth Kumar S, working as an assistant professor at Mysuru Royal Institute of Technology. Today I am taking the module of Fourier series. In this module you are going to study Fourier series of period 2 pi, Fourier series of period 2L, and next practical harmonic analysis. Next you should know the application of Fourier series. It plays a very vital role in the field of computer science, in the field of electronic science. So first thing we should know what is periodic function. So consider a real valued function called f of x, a real valued function called f of x. Then consider a period called t. Then we have f of x plus t equal to f of x. If we get back with f of x, if we make sure that f of x plus t equal to f of x, then we say that the given function is a period of t, is a period of t. For example, if you consider example, sine of x plus 2 pi is equal to sin x itself. So therefore we say that this function sine is a period of 2 pi. Similarly, cos of x plus 2 pi is equal to cos x. So again we can say that it is a cos x is a period of function 2 pi. So using this concept of period t, we apply this concept to find the Fourier series of any function using period of arbitrary period 2L or period 2 pi. Now as you came to know what is the definition of periodic function, now we shall define a Fourier series. A Fourier series is defined as a way of representing a periodic function as a sum of cosine and sine functions. A Fourier series is a representation of a constant with a sum of cosine function cos n x plus summation n equal to 1 to infinity bn sin n x. This is the representation of Fourier series, where a0, an, bn represents Fourier coefficients. That is we are going to find out. Now we shall see the general representation of Fourier series for period c comma c plus 2l, c comma c plus 2l. So how to find out the period of the given function means this is upper limit and this is lower limit. Upper limit minus lower limit, upper limit minus lower limit gives the period. C get cancelled, you are left out with period 2l. It is a function, a general representation of a function called c comma c plus 2l, and we can say that it is a period 2l finally. We shall go for a general representation of Fourier series for period c and c plus 2l. So it is given by f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by l plus summation n equal to 1 to infinity bn sin n pi x by l. This is the representation of a Fourier series in general form. Now in this we have a distribution, of period. You may have the period like 0 comma 2l. If you substitute the c value as 0, c equal to 0, put c equal to 0, what you are going to get? C as 0 comma 0 plus 2l is nothing but 0 comma 2l. Similarly 0 comma 2 pi, we can also have 0 comma 2 pi. Put c equal to 0, we get 0 comma 0 plus 2l. Instead of l I am considering pi, 2 pi. So let us see what is the formula for the period 2L here. We can find the period here 2L minus 0, which is nothing but period 2L. So now how we represent the Fourier series for such function? It is represented as f of x. There is no change in the general form if the period is 2L. I showed you how to find the period 2L here. This is general form. So we can have f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L plus summation bn n equal to 1 to infinity bn sin n pi x by L, n pi x by L. Now we shall find out. We require to find out Fourier coefficients of period 2L. How to find out? Let us see. A naught is given by 1 by L integral. Observe here the given limits 0 to 2L. Write down the limit 0 to 2L in the integral sign. 0 to 2L f of x dx. Next an is given by 1 by L integral 0 to 2L. The given interval is 0 to 2L f of x cos n pi x by L dx. Next bn is equal to 1 by L integral 0 to 2L f of x sin n pi x by L dx. This is the Fourier coefficients. This gives a naught, an, bn represents Fourier coefficients. Once you came to know the values of a naught, an, bn, substitute in the Fourier expansion. We are going to get the series expansion of the given function of period 2L. Similarly, sir, what we have, don't think that we have so many formula. I will make you simple as possible. I will make you very simple. See here, how to find out, how to substitute the formula for period 2 pi. See here, well, we have a change in the interval. Instead of 0 to 2L, we have 0 to 2 pi, that's all. Instead of L, what we have? Instead of L, we have pi. Just go on substituting wherever you have L, substitute the value of pi. That's all you are going to get. So therefore, f of x will be what? Come on. F of x is what? F of x is nothing but a naught by 2 plus summation n equal to 1 to infinity an cos. Now observe here, cos I am substituting in place of L, what I am substituting? Pi. So pi by pi get cancelled, you are left out with what? Cos nx. So it is cos nx. It is what? Cos nx plus summation n equal to 1 to infinity bn. Similarly, sin of, substitute here L equal to pi. So pi get cancelled, you are left out with what? Sin nx. This is the general form of Fourier series for period 2 pi. So upper limit minus lower limit 2 pi minus 0 gives 2 pi. So now let us find out a naught. What is a naught? You can only tell me what is a naught now. Just substitute in place of L, just substitute pi. So 1 by pi integral, see the interval 0 to 2 pi they have given, 0 to 2 pi f of x dx. Next bn, an equal to, next an equal to 1 by pi integral 0 to 2 pi, observe here 0 to 2 pi f of x cos, I am just substituting in place of L, pi. So pi get cancelled here, pi get cancelled. If you substitute L equal to pi get cancelled. So therefore you are left out with cos nx dx. Similarly, bn equal to 1 by pi integral 0 to 2 pi f of x, what? You are left out with sin nx. Yes, very good. It is, you are left out with sin nx dx. This is the formula for this is the Fourier coefficients for the period of 2 pi, period 2 pi function. Next, Next we can also see the period 2L and period 2 pi in another interval. So just I am going to change here. Just I am going to change, instead of 0 to 2L I will consider minus L to L. So now clearly you should know what is the period here. See here, upper limit is L, minus of minus L lower limit, which is equal to L minus of minus L gives L plus L, which is equal to 2L. You are getting 2L. Okay, so the formula is same, the periodic series is same, period, as the period is 2L, so we can represent the Fourier series expansion as same. So f of x is given by a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by L plus summation n equal to 1 to infinity b n sin n pi x by L. But while finding the Fourier coefficients called a naught, a n, b n, observe the interval, interval is given in terms of minus L to L. So just replace the intervals, that's all. Just change the interval minus L to L, minus L to L, minus L to L. This is the formula for minus L to L. Okay, similarly we can also find minus pi to pi for the interval minus pi to pi. It is a period. We can check for periodicity. So pi upper limit minus of minus pi is equal to pi plus pi becomes 2 pi. It is a period 2 pi. So here also again same formula for Fourier series expansion for period 2 pi. The period has not been changed, that's why the function will the Fourier series expansion will be remains constant. So only change in the interval, therefore change the limits, that's all. Change the limits, it becomes minus pi to pi, minus pi to pi, minus pi to pi. So now I think it is easy to understand and it is easy to remember all the formulas. So I have defined for period 2L and I have defined for period 2 pi how to write the Fourier series and how to write the Fourier coefficients. Okay. Sir, what is the difference between period 2L and what is the difference between period 2 pi? So period 2L is nothing but arbitrary constant. You can have the problems like you can have the constants functions like 0 comma 3 minus 3 comma 3. You can have like this. This is the example for arbitrary constant. Arbitrary constant means L can have any values, any real values you can have. So that is the constant, that's why it is named as arbitrary constant period 2L, and here we have period 2 pi. So this series is called as full range series. This series is called as full range series. So that's why we are finding periodic functions of period 2 pi and period 2L. Okay.